Okay, this video is a continuation of the last video in the infinite series section for AP Calculus BC. We went through how Lagrange error works for Taylor polynomials and how it compares to alternating series error. And now we're going to work one last question. This one is the actual FRQ for this topic on the 2011 AP Calculus BC free response in the actual exam. And we would be working this problem in groups at the end of the lesson in class. So let's take a look at it. It says, let f of x equal sine of x squared plus cosine of x. And they give the graph of the fifth derivative of x, shown above over a region. It says, A, write the first four non-zero terms of the Taylor series for sine of x about x is 0, and write the first four non-zero terms of the Taylor series for sine of x squared about x is 0. B, write the first four non-zero terms of the Taylor series for cosine of x about x is 0, and then use this series and the series for sine of x squared found in part A to write the first four non-zero terms of the Taylor series for the given function f about x is 0. Right? Then it says for part C, find the value of the sixth derivative at x is 0. And then for part D, it says let the fourth degree polynomial, P4, be a fourth degree Taylor polynomial centered at 0, and then using information from the graph, show that the difference between the Taylor polynomial at 1/4 and the actual function at 1/4 is less than 1 over 3,000. All right, typical question. This is usually question 6 on the AP exam as a unit infinite series question, and it's very often formulated like this. So let's take it down. We'll do the first 3 parts, and then we'll do the fourth part separately. Okay, so here's a function. We don't need the graph until on the last question. Write the first four non-zero terms of the Taylor series about sine of x, about x is 0. Here's the reason why you need to have this memorized. So I'm going to write it down real quick, and then we'll write down the result. I've memorized that e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial, and so on. Starting with c before s, cosine, sine, cosine, sine. The sine, so for part A, the sine of x is these terms. So it is x cubed over 3 factorial. They're saying to write the first four non-zero terms, x to the fifth over 5 factorial, x to the 7th over 7 factorial, and it's an alternating series starting with positive. This is the reason why you need to have these memorized, because very, very frequently they ask questions involving e, sine, and cosine, and if you had to derive this by doing the Taylor polynomial procedure, it would take too much test time. All right, so that's the first thing. That is the Taylor series for sine about x is 0. Now, write the first four terms of the Taylor series for sine of x squared. So for that, we simply replace the x's with x squareds. That's going to be x squared to the third power. Let me write it out. X squared cubed over 3 factorial, and then plus x squared to the fifth over 5 factorial minus x squared to the 7th over 7 factorial. And I'm going to simplify this. This is x squared, and this is minus x to the 6th over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial. So that's part A. Just being able to recall those, I mean, super quick, right? All right, part B is write the first four non-zero terms of cosine. So cosine are the other terms from E. Cosine is the 1, the x squared over 2 factorial term, the x to the 4th over 4 factorial term, and the x to the 6th over 6 factorial term, right? Right, and it's an alternating series starting with positive, right? So that's the first part of that question. Let's say they said first four terms. So should you put pluses on here? I don't think so, because they said to write 4 terms. All right. They also said series, so should you put plus or minus? I think there should not be pluses here. Let's actually look at that really quick, because I have the solution as well. This is from their grading rubric. Oh, they actually put the ... So since it is a series, we probably should put the ... on there. So let's do that. To indicate we know it's from a series, we will put the ... because series means infinite. Okay, so that's cosine. We've written the first four terms, but indicating it's a series. Okay, then it says use this series and the other series to write what f is. Okay, so f of x is sine of x squared plus cosine of x. So combining those series, first we have the series for sine of x squared, which is x squared minus x to the 6 over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial plus blah, 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 blah. And then we're going to add onto that the series for cosine, plus 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on. And then I think we should write this in a little bit nicer form so we can work with it. What's the lowest degree thing here? That would be the 1. So we'll start with the 1. There's no x's, but there are two x squareds. There is a 1, and then there's a minus. So this is plus 1 minus 1 over 2 factorial x squareds. Right? Then there is an x to the 4th. That is the next term. And that is 1 over 4 factorial times x to the 4th. And then the next thing is a 6, x to the 6th power. There is a negative 1 over 3 factorial and a negative 1 over 6 factorial, x to the 6th term, and then this continues. And they said to write the first four non-zero terms, so that's 1, 2, 3, 4. So at this point, I've written those. Now, what we could do, maybe not a bad idea, because we might need to do some calculations, is let's calculate what these are. So 2 factorial is 2, so 1 over 2 is a half. 1 minus a half is a half. So the most compact way, simple way to write that is 1/2 x squared. This is 4 times 3, which is 12, times 2 is 24. So this is plus 1 over 24x to the 4th. And then I would, well, actually, usually this is usually on the non-calculator part of the test. So how could we simplify that quickly without a calculator? So that would be negative 1 over 3 factorial. That's 3 times 2 times 1 minus 1 over 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Well, if I want a common denominator so I can combine these things, this is going to be, I'm going to have to multiply this by 4 times 5 times 6. So I have to do 4 times 5 times 6 up here. Then I've got this, which is 6 times 5 is 30. 30 times 4 is 120. So this is times a negative 1 here, right? So this is going to be negative, let's see, 30 times 4 is negative 120 minus 1 over that whole 6 times 5 times 4 times 3 times 2 times 1. Does that simplify it all? That's negative 121 over 6 factorial. That's a pretty compact way to write it. Let's write it that way. I guess we can figure out what this is too. Is that going to be helpful? Yeah, let's do. So what is that? 6 times 5 times 4 times 3 times 2 times 1. So this is 30, and 30 times 4, that is 120. And then 3 times 2 is 6. Let's just do a 6 times this. Sometimes you have to do this on the AP test because it happens on the non-calculator part. 6 times 0 is 0. 6 times 2 is 12. 6 is 720. So this is negative 121 over 720. That's the most compact way to write this. So this is negative 121 over 720 x to the 6th. Okay, so that is the f of x. So now we've met the full requirement for A and B, and I've done a lot of simplifying as well. Okay, so now let's go on to part C. I'll use green for part C. It says find the value of f to the 6th to the 0 power. Now that seems really weird. We weren't given the function. Well, we were. Now we could take 6 derivatives of this, but man, that would be a lot of work. I think there's a more clever way to do that. Would you agree, though, that this is the 6th derivative should be part of the x to the 6th term, right? If I had this x to the 6th term, this should be the 6th derivative evaluated at the centering value, which is 0, over 6 factorial And then this should be x minus the centering value to the 6th. You agree with that? And this 720 is 6 factorial. So that means just by comparing, right, this f to the 6th evaluated at 0 is negative 124. So by inspection, f to the 6th of 0 matches with negative 121. I said 124, I meant 121. So this would just be negative 121. It's just the top of the fraction for the 6th power term, 6th degree term. All right, so that's how you do the first three. And hopefully this illustrates that, sometimes AP questions are not overly complicated, although there's a lot going on here. And this would be very hard to do if you didn't memorize the sine and cosine forms. Okay, now let's do the part that's related to the Lagrange error. Part D says, let P4 be the fourth degree Taylor polynomial for f about x is 0. Using the information for the graph, show that this expression is less than 1 over 30. All right, so I would write this, that the error, which is the difference between P4 at 1 over 4 minus the function, is less than or equal to the Lagrange error. And we know that that is f to the n plus 1, that derivative evaluated at z, over n plus 1 factorial, x minus c to the n plus 1 power. And in this problem, the n is 4, the x value is 1/4, and the centering value is 0. So now I can start filling this in. This is f n plus 1. So that's actually f to the 6th, right? I'm sorry, f to the 5th. Because if n is 4, this would be the 5th derivative evaluated at z over, let's see, n plus 1 is 5 factorial. And then this would be 1/4 minus 0 to the 5th power. The last thing we have to figure out is, what is this, the maximum value of the 5th derivative at z between 0 and 1/4. So this is where we use their graph. They gave me a graph of the absolute value of this function. So here is the centering value. 1/4 is there, right? Is that right? Because that's a half, right? So that means that this is maximum up here. And I'm thinking that this value here is somewhere between, let's see, this is 20, so that's maybe around 30. I don't know for sure. It's somewhere between 30 and 40. So you could pick a number in there, or you could just say, I definitely know it's less than 40. Maybe I would estimate it at 35 to be safe. Okay, so I'm going to say that this is less than or equal to 35 over 5 factorial 1/4 minus 0 to the 5th. And what we're trying to show is that this is less than 1 over 3,000. All right. So let's see if we can show that. Well, what is this? 35, we have 5 times 4 times 3 times 2 times 1, and this is on the non-calculated part of the test. We also have 1/4 to the 5th power, which means this is a 4 to the 5th power, right? So we've got 35, we've got 5, 4, 3, 2, the 1 doesn't do anything, but I have 5 of those 4s down there. I'm just thinking, can I somehow combine them in some way to show that this is less than 3,000? Well, maybe I could do this. This makes this a 7. And then what would this be? 4 times 4 is 16. 16 times 16 times 16. So what is that? 16. 16 times 16 is 6 times 6 is 36. 6 plus 3 is 9. 16, that's 256. And then if I multiply that by another 16, that is 6 times 6 is 36. Let's see, 33, 12, 13, 14, 15. And that would be 6, 5, 2, 6, 8, 10, 4. So we're already less than that, right? Then that number would be times 6, right? Times 6. Actually, here's what I would do, okay? I would say this is equal to, this is a 6, right? So now we have 7 7/6, and now we have 1 over 4,000, and I can't read my writing there. That is 6 and 3 is 18, so 8/6. 7/6 times that is less than 1 over 30, 1 over 3,000. Is that true? I guess we have to continue. So 4,086 times 6 is 6 times 6 is 36. 6 times 8 is 48. 51. And 6 is 24. But then you'd have to take that and divide it by 7,000. Wow. Okay. So 2, 4, 5, 1, 6 divided by 7 is, let's see, 7 times 8, 7 times 4, 7, 14, 20, 28, 7 times 3 is 21, 3, 7 times 5 is 35, right, so that's 0, so 1, that's 0, and then this is 16, 7 goes into that 2 times. All right, so this is approximately 1 over 3,502, which is definitely less than 1 over 3,000. We have shown that the error is less than 1 over 3,000. All right, perfect. So this is the way they typically ask questions about Lagrange error. And if we look at their particular rubric, let's see what they did. They wrote out the sine, they plugged it in, they wrote out the cosine, they combined them and simplified. They sure enough said that this is the form for the coefficient of the x to the 6th, therefore this is negative 121. And when they estimated it, they went ahead and just rounded up to 40 when they did that, which made their math simpler, actually. But the same idea. They ended up with 1 over 3,072 for their value. All right, so that's a typical way how a problem could appear on an FRQ. And unfortunately, it's usually in the non-calculated part of the test.